All right, class, for number 2, I'm going to show you all the other transformations that could possibly happen. Number 1 had 4 transformations, and this one has the other 3 that could possibly happen on this test for on level. So I'm going to show you these 3 transformations, and let me show you each one here. Okay, so the first step is always to find the up, down, and left, right transformations. That -2 there will be a vertical shift down 2. So that's a vertical shift down 2, and you can see that in Desmos. If you put the -2 on the end, you see that shift down 2 that the purple made from the original black parent function. All right, so the next thing I need is this one right here, this value, this +2. And remember, it does the opposite. It does a horizontal shift to the left to positive. I know you think positive is to the right, but on these problems, since the initial function is x minus h or x minus c, it's going to do the opposite. So it is going to be a horizontal shift. And this is going to be to the left 2. And now that I've done the up, down, left, right, I'm going to graph that. I go down 2 and to the left 2 from the origin, because remember the parent's at the origin, so you go down 2 to the left 2. And let's go see that left 2 now on Desmos. See, we're right at the origin, and then I do a +2, and it shifts it to the left 2, that purple one. All right, so it shifted it to the left 2. And the last one I'm going to look at that's going to decide how I'm going to graph this is this one right here, your A value, and that is our rate of change, and it is 1/3. And remember, a number less than 1 causes a vertical compression. You should remember that from your notes. That's a vertical compression by 1/3. So it caused a vertical compression by 1/3. And let me show you what that means. On Desmos, when I put this 1/3 out here, watch what it's going to do to this graph. It's going to compress it, kind of like flatten it vertically, because it's going to start going up slower. 1/3, like that. See, now every time you go up 1, you go over 3. Up 1 over 3, up 1 over 3. It's going up slower as compared to how fast it's going left and right. So it causes a vertical compression by 1/3. And the way to graph it without using Desmos or anything is you go up 1 over 3, up 1 over 3, up 1 over 3, like that. Treat it like a rise over run. Rise over run. You're going up 1 and then over 3. And then on the other side of the vertex, you'll go up 1 and to the left 3. And then up 1 and to the left 1, 2, and then it's like this next point out here. And there is my graph. See how it's real flat because it got a vertical compression because it's going up so slow. All right, so my vertex was at -2, -2. So the vertex is -2, -2. My domain is always the same. It goes from -infinity to infinity. Let's zoom in a little bit. -infinity to infinity. My range is going to be, remember, the lowest and the highest. Low and high. Now this time, my lowest point is right here at the vertex. So that means my vertex is a minimum, since the lowest point on this graph is the vertex. And so the lowest point is at -2. And then how high does it go up? It just keeps going up forever, all the way to infinity. -2. Oops, I need to do an include there, a bracket, because that does include -2. Remember, for infinity, it's always parentheses, because you can never actually get to infinity. But we do hit -2 on this graph, so you're going to put a bracket there at -2. All right. So the next thing we need to find are our x and y intercepts. It looks like the 2 x-intercepts hit perfect. See here at 4, 0. And over here at 1, 2, 3, 4, 5, 6, 7, 8. Because remember, it hits at, this is 5 right here. 1, 2, 3, 4, 5. And then up 1, 6, 7, 8. So negative 8, 0. But we're going to check that by solving for the x-intercept as well. The y-intercept does not hit at a point perfectly, so you're going to have to figure it out. All right? So let's go ahead and solve for the x and y-intercept next. Okay, so for the x-intercept, you set y equal to 0. Let me bring my formula down here. 1/3 absolute value of x plus 2 minus 2. All right, so I set y equals y equal to 0 right there. So the x-intercept's usually the tougher of the two. So I got to plug in 0 equals 1/3 x plus 2 minus 2. All right. And now I need to solve for x. I'm going to do plus 2 to both sides, plus 2. And so I get 2 equals 1/3 x plus 2. And then I'm going to multiply by 3 to get rid of the 1/3, and that'll cancel out my 1/3, and I get 6 equals the absolute value of x plus 2. And now that my bracket is by itself, the absolute value bracket is isolated, I can go ahead and split into my two equations. X plus 2 equals 6. X plus 2 equals negative 6. So do a minus 2 to both sides. You get x equals 4. And on this one, you do minus 2 to both sides. You get x equals negative 8. And those both matched what we got, 4 and negative 8, so that works. Now let's do the y-intercept. And remember, for the y-intercept, you always set x equal to 0, so we're going to plug in 0 right there. So we get y equals 1/3 0 plus 2 minus 2. All right, and 0 plus 2 is 2, so I get 1/3 times 2 minus 2. 1/3 times 2, think of that as 2 over 1 and multiply it. You get 2 over 3, right? Minus, and I'm going to change this to a 3 on the denominator by doing times 3 over 3, which is 6 over 3, right? 2 over 3 minus 6 over 3 equals negative 4 over 3. So my y-intercept is negative 4 over 3. So it's 0, negative 4 over 3. And does that look good? Yes, it does, because I go down 1 and then I go down a little bit more, because negative 4 over 3 is negative 1 1/3. And so that works. And the next thing I'm going to find is my axis of symmetry. And remember, for axis of symmetry, you go to the vertex and chop it in half with a vertical line. And remember, a vertical line is always x equals something. So it is x equals, your axis of symmetry will always be x equals, and what is x here? Start at the origin, negative 1, negative 2. X equals negative 2 is my axis of symmetry. All right, that is everything for number 2 on our review.